Anyway,
I fell asleep.
this is a little presentation of finding electrical problems. And this is not a canned presentation I've already put together. This is something brand new. I'm trying to put together as many brand new ones this semester as I possibly can, so I'm not repeating myself. But what we're looking at here is we gotta, to begin with, we gotta understand volts versus amps. Okay? All right, I've got an engine started here. I got an alternator charging. I got stop lamps that are illuminated. Okay? Each one of these little sets of stop lamps pull 4 amps each, and this high mount stop lamp pulls 1 amp. Right? So how much does this total circuit pull? 5 amps as far as what you're looking at right here. Okay, how many volts do you have right here?
12 or, yeah, it's about 12.
How many amps you got?
I'm not sure.
Depends on the battery. How much are these pulling?
So if it's just, I mean, if it's, that's the only thing pulling it.
Exactly, exactly. I mean, for our purposes, this is the only thing we're gonna be measuring, right?
Yeah.
So you got 5 amps there. Okay, how many volts and amps here?
Or,
Should be the same.
You
yeah.
notice your amp measurement is taken with an inductive lead like you guys were doing earlier today. Okay, the same thing, 12. All right, now then, how many volts and amps here?
It should be the same.
The same. What about volts and amps here?
I don't know. You're gonna
I
have.
don't
We're down
know.
on the ground side, now that's the body of the car.
Please.
How many volts, how many amps?
It's 0, isn't it? It's 0, 1.
0 volts, but 1 amp,
Alright.
right? So the amperage is gonna stay the same throughout the circuit. The voltage is gonna be, because you're always using ground for a reference point, so you're not gonna read volts here, but you're gonna see amps, because amps is always flowing everywhere. All right, right here, what about this place? Volts and amps there,
2.
4 amps each. 12 volts, 4 amps, right? Actually, I messed up on that. 4 and 4 is 8 and 1's 9.
That's
If it's a 4 amp
say.
lead. See what I'm saying? I screwed that up, boy. So
Both-
that would have been 9, 9, 9. Man, I was sleepy when I did this, I guess. But anyway, one way or another, the point is your voltage is going to be the same throughout your circuit if there's not a resistor anywhere. But your amps is, your volts is going to only be, here amps is going to be the same everywhere. That's the whole rule. So amps is the same everywhere, volts is only going to be read on the positive side. Okay, now the voltage drop measurement is what I was showing you guys this morning. All right, I've got these meters right here. I got 3 meters. I'm meter rich. I got all kinds of meters here. This is supposed to be driving this motor. And basically, I don't even have a switch in there. I've just got this circuit driving this motor. This is a circuit right here. All right, I've got 11.82 volts at my source. I've got 11.82 volts at my load. The load is literally dropping every bit of what's put into it. But you're going to read the same thing. I've lost, this is a microvolt, tiny, tiny, tiny little amount, because you're always going to have a little bit of loss there. I mean, through wires and connections or whatever. This right here is with a resistor in it. I've got a 1 ohm resistor I've inserted. You notice it's not there. And I got 11.84 here. I got 10.53 there. And I got 132 here. If you added this one and that one together, you get that one. You understand what I'm doing here? The voltage is being dropped right here. That's what voltage drop is all about. This is a little thing. You'll never see another example like this anywhere. Everybody pay attention. Nobody play with your phone. Every part of a circuit, even the wire, has at least some resistance and will drop some voltage. That's just the way it is. When the switch is on and current's flowing, resistance causes some of the voltage and current not to make it to the load. Sometimes resistance is built into a circuit like right here. And you know what this is, right? You know what it is?
Switch.
Lower resistor. This part right here. Now you gotta pay attention. I'm gonna start giving you guys a written test that you have to make little marks on, because you're sitting here tuning me out. And I ask a question, they say, huh, what? You know what I'm saying? I know you're not paying attention. Limits the speed of the blower motor. That says 1.3, that's 0.62, and that's 0.33. How much current is that? Excuse me, how much resistance is that?
62, what?
0.62, 0.33, and 1.3. That is the total resistance of that circuit.
95 plus, what was the last one, 33?
1.3.
Yeah. Can you see it there?
That's still.
93 plus whatever the last one
Yeah.
So 1.3, 62 and 0.33.
2 1/4. All right, now what you got right here is you could measure a voltage drop here, here, and here. Did you guys see me doing that earlier? With that resistor? Voltage drop measurement could be taken from here to here, and you could determine how much was being dropped all the way across. So you got 12 volts here, 2 1/4 ohms. You can measure how many amps is there. So you got, 5.3 amps is being pulled here. All right, got that? Now, there's the places you don't want voltage drop. I drew this a long time ago with paint on Microsoft Word. But basically, you're measuring, always when you're measuring voltage drop, you're measuring on the same side of the circuit. You're actually going to start with a positive battery terminal. If you can get to that sucker, that's where you want it. And you're basically going to go to the negative side of the starter. On the positive side, that's the negative terminal. On the positive side, you're going to start on that terminal and go back around here. I've actually got a video where I was checking that on Amber's vehicle, and she had what looked like brand new battery terminals on it. But they were the kind that you clamp down. And a lot of these, they paint them black and red, and the black paint was keeping any of the current from going to her battery terminal on that car.
How did you learn to draw so good on that?
I drew that on paint.
I know how.
Oh, I don't, I'm artistic, I mean, just call me Pablo Picasso with paint. Anyway, so right here you got, I know what I want it to look like, and I paint it the right color and all. And I got it on the 2-volt scale. You're allowed to have 1/10 of a volt of voltage drop on the ground side and 1/2 volt on the positive side. That's a general rule of thumb. That's what I learned when I went to Mazda school in 1983 or whatever it was. We were talking about that. All right. Now, bad connections are possible anywhere there's a connection, including the innards of a switch or in a connector or whatever. Current flowing through resistance creates heat. Heat oxidizes a connection, makes more heat, more resistance is created. I actually put those backwards, more resistance and more heat is created. A plastic connector shell begins to melt, things continue to deteriorate until current stops flowing. I was in a manufacturer school one time, and there was a guy that was teaching that class that had never, as far as I know, fixed a car, but he was pretty good at teaching, and he was trying to convince the ones of us in the class that were there that resistance doesn't make heat. And everybody was rolling their eyes, but nobody wanted to take him on except me. I says, why do they make resistors out of ceramic? If it doesn't take, I kept pushing until I finally said, well, I guess, I can see your point. I don't know where he came up with that. I mean, that must have been something he dreamed or something. I don't know what it was. The blower resistors are mounted in the blower's airstream to keep them cool because resistance makes heat. You see the blower resistor? That looks vaguely similar to what I got over there, doesn't it? All right, and so this little thing right here is a thermal limiter in case for some reason the squirrel cage quits blowing air and there's still current flowing through here. This thing gets to a certain temperature, it opens the circuit so the fan doesn't work at all. And I have gone to Radio Shack when I would see one of these, and they wouldn't have a blower resistor in stock, but this would be all that was wrong with it because of whatever reason it got hot, no other problems. And I'd go to Radio Shack and I'd buy one of those things, and I'd put some little clamps on it to keep the heat from going up in it, and I'd solder a new one on there and fix the blower resistor. But this was about $1.50, Anyway, but you might notice it's always in the airstream so that as the air blows across it, it'll keep it cool because there's no big heat. When we were hooking that fan up to that resistor on the table over there a while ago, you might have felt it getting hot, and it was actually starting to warm up pretty good. Now, when you're troubleshooting an operative component, the first thing you got to do is you got to understand the circuit. Now look at here. This is something I want you to pay attention to, and I don't remember actually ever talking about this in class before. On this particular fuel pump circuit, you got the fuel pump relay, and the powertrain control module is just basically reading that line to make sure that it's hot. Because the powertrain control module knows that when it turns on the relay, it should see power here. The powertrain control module also knows when the relay disengages, it should see a ground there coming back through this pump, right? There's your inertia fuel shutoff switch. This is a little 97 Escort. Okay, so right here you got two wires that are going to the same place. You see that? That wire and that wire are spliced together. Now, why do you suppose they would do that? Because the two wires are sharing the load. less likely to have a problem there. Pretty good idea, and I've seen it done more than once. Doesn't happen a whole lot, but you will see it. And whenever you see two wires coming out of the same connector going to the same place, that's the reason for it. All right, so now then, first thing we're going to do, now that's what basically I put that right there. But this particular one here, this little bunch of relays is in that little box right there. And that particular terminal right there is this one here. So if I go to that terminal and I back probe it with a little T-pin, and I touch it hot to here, and that ground should be coming all the way through everything, and it should light that light. If it doesn't light the light, I know something's wrong. I'm going to check the inertia switch, which is pretty easy. Inertia switches, by the way, can develop resistance and burn up. I've had to replace inertia switches that were burned up. A lot of the times the switch will come with a connector shell and a couple of new terminals in the box. Test light connector between pin 5 and B plus should show ground. That's what I was talking about there. Low impedance test light is the one where the bulb pulls some current. A high impedance test light is like an LED. And it is pretty much doggone useless. I always try to use a light if I can that's got about the same amount of current draw as the thing I'm checking. You know what I'm saying? Like if I'm trying to see if a fuel pump is going to run with the current that's got delivered to it, I get a headlight bulb because that pulls about as much as a fuel pump that's pumping fuel. If the fuel pump's not pumping fuel, it only pulls about 1.5 amps. All right. Now, this is the same vehicle, but 2 years newer. Never assume you know the circuit. Oh, I've worked on these escorts before. I know how this is wired up. On this one right here, if the test light strategy won't work, but you can measure that. Look what's in between the pump and the fuel pump relay. All right, this goes here, and you might notice that it's got a little black triangle with a K, and it's got another one over here telling you that it goes off the page right there and comes back in on that parallel universe over there. Okay, so it's going through this module. The module is controlled by the PCM. Why does the PCM have a module between it and the fuel pump? Got any idea? It controls the speed of the fuel pump. And this sensor right here basically tells the PCM how much fuel pressure it's got, and it can actually cause the fuel pressure to go up and down based on what the PCM wants. It's a closed loop fuel system. Kind of like on a GDI vehicle, but this is a 99 Escort. That's what it is. All right, but what I'm getting at is, you need to look at a map. The path the current takes through the fuel pump relay to the fuel pump, it encounters all of that stuff. So if you put a test light here on this one, you're not going to see a ground. All right, you got to make sure you know what's in that circuit before you start trying to troubleshoot it. Okay, the 2004, actually it was 2003, Chevy Silverado from last week. Austin's going to remember this. The throttle control was dead. We got a no-com fault between the ETC module and the PCM. Instrument cluster message center was reporting reduced engine power. You put your foot on the gas all you want to, you aren't going nowhere. All right, now this is what we had right here. We basically had these two schematics and these two connectors. This particular connector here was hooked into one side of the module, and this one here was hooked into the other side of the module. This one here was hot, those two were ground. That was the way it was supposed to be. I checked all of the other ones. I didn't have ground on those anyway. All right. Now, whenever we went to this fuse right here, I told, you remember, Robert, I told you, I says, go look at that fuse, and you went and looked at the fuse, and you come back, and it was toast. Its fuse is no good. So we went and got another fuse, and this is what happened. Did you know how fast I was to take a picture of that fuse while it was blowing?
You got lucky.
Yeah, actually, it was a video, and I framed it forward until I found where it blew. But that's what it looked like, and it was really bright. You know, in that, I couldn't believe it was that bright, because it didn't look that bright to us, did it? When we replaced the fuse and turned on the ignition, the fuse blew again like a flashbulb. And all we had to do was just plug that one connector into the module and go pop. So I said, aha, that's not too bad. Now, look at this a little closer. There was only one ground wire, going to pin 15. The rest of it was going to the throttle body, right? Now, why do you suppose, and I'm surmising here, why do you suppose GM put a module in between the PCM and the throttle body?
I seen something where, I don't know if this is why they did it, but even though you're trying to give it so much gas, it'll let off or give it more gas depending on, I guess, the engine load and all that.
Well, it wants it to be fast. And the processor speed in the engine controller they were using back when they first started doing this, I know when Ford did it, they used a totally different processor. They used an entirely, a black oak processor, which was a different box. It was a totally different computer. The computer GM was using, if you look at the one on the 99 GMC that's got a cable, and the one on this one, the PCM, is the same PCM, probably got the same processor in it. I'm guessing at this, but I'm thinking they did to put that little piggyback throttle control so that it would actually make the decisions really fast. Anyway.
Well, I mean, for what though? Make
He
a
was
decision
under
for
the lead.
what?
Huh?
Make a decision for what?
So you wouldn't
To
have
the,
to
for the
go
throttle, when you're putting your foot on the gas, it's got to instantaneously, I mean with no lag. If you put your foot on the throttle and the gas doesn't move, you're sitting here waiting and then all of a sudden it takes off. You don't want that. You want this thing to be instantaneous. And I'm thinking the original engine controller wasn't fast enough to make that happen. So they moved the processing over to this thing and just let the engine controller make a request.
So you're saying the PCM couldn't read your response quick enough?
It couldn't respond quick enough.
It's reading it, but it's not getting to the throttle bar.
Yeah, it's not getting it fair fast enough. Now later on, I'm sure they did away with that. But anyway, but the only one line to ground. There was two wires that were grounded, and the other one went to the center high mountain stoplight. And whenever we meshed the brake, that ground went away, which told me that with the ground that route, we're reading through the high mountain stoplight. So they shouldn't have blown the fuse. Nothing else was going directly to ground. Now, if we had a wire shorted to ground somewhere, but look at all this 5-volt reference, low reference, you know, motor control and all that. I mean, I suppose if you had a short on that one or one of these. Now, I'll tell you something about electronic throttle control. It's not just pulling the throttle open and letting the spring close it. It drives it open and closed. So it's driving it both ways. You see what I mean? I mean, so just remember that. You might think because when you mash it and the spring pulls it back, but it's actually controlling it in both directions, even though it's spring loaded to the closed side. But the ETC module had to be the problem, so I went to the salvage yard for $48. I came back with another box. We plugged it in and it's on there now. Now, here's a soft skills question. If you ask a person in charge for permission to take something that belongs to the company and a person says you can take it, who bears the most guilt?
Person in charge for letting them take it.
You for doing it.
The person in charge actually gave you property he didn't own, making the person who gave it to you more responsible. You understand why I have a little bit of a problem with somebody saying you got a quart of all I can have? Or you see what I'm saying? Or the student from the electronics department that came and says, I need a fuse for my car. And I says, why does the college owe you a fuse? You know, he may steal a fuse and give it to you or what? You know, oh, I need a fuse. So I went and got one out of my car and put it in, you know, in a box in my car. Give it to him.
Or just go ahead and steal all your tools?
Yeah. Yeah, there's people that do that too. But anyway, the blower motor on this one wouldn't work on high speed. This is a different Silverado. I think you were involved with this one. All right. So, what are we looking at? Blower won't work on high speed. Don't talk. Don't say a word if you know what was wrong. Where would you go first? Blower don't work on high speed. Look at the schematic. Whenever it's off, you got nothing. You got power feeding here through all these resistors. You remember the blower resistors I showed you earlier? And it's going through the normally closed terminal on that relay to the blower motor. It works on every one of those speeds, but when you turn it to high, it's actually supposed to energize that relay, and it's supposed to pull power from here, and the blower is supposed to run wide open. That's it. He's talking. I knew it. He's fired. Get out. What do you think? Where are you going to look, guys? Tell me about it. Don't play dumb. Think about it like you were trying to fix the truck.
Oh, we can talk about it.
I can't talk.
He can't talk about it because he knows what it was. The rest of you can think about it and give me an answer instead of trying to get him to whisper it in your ear.
I wasn't getting the whisper in my ear.
Oh, well, you were talking though.
We were
All right,
discussing
so-
the problem.
What do you think? What do you think wrong? Tell me what the deal is. Where would you look?
In the truck.
Funny how these little thing amuses him, isn't it? the blower, okay? That's the blower fuse. Now, you remember we went and looked at the blower fuse, there's a big old fuse in there. Nothing was wrong with it. That big old fuse right there didn't have any kind of a problem. All right, now right here, what we've got, we got under there, he turned it on high blow, and sometimes it would work and sometimes it wouldn't. That's telling me it's probably not the fuse too, right? Sometimes it would work, sometimes it wouldn't. So I got up under here and I tapped the blower resistor, which has the relay built onto it, and it kicked on high. And I said, this thing's got a bad blower resistor. Okay, now the problem with that is a lot of the times you'll see terminals that are scorched and burned where the wire's plugged into the blower resistor. We didn't see that on this one. There's the relay that I tapped on. It's built into the resistor. You can't change it by itself unless you want to be really creative. This right here, these terminals right here, I didn't see anything wrong with these terminals here. The blower kicked on high and worked when we touched it, and the whole thing would need to be replaced. Well, the problem is, we got this darn business going on. They sent this from the part house, which looks a lot like this, but these holes were too close together. This cover was mounted on this original resistor so that you would have screw holes that were far enough apart where you could mount it up in there. There was no way I could mount that one. I mean, I guess you could have put silicone around it or something, but I said, this is not working. And did you know, whenever I asked them about it in the parts store, they came back with the same one and they said, look, there's a paper in the box that says it doesn't look the same, but it'll work. Well, it won't either. It's physically not able to work. I mean, I can't get it, you know, it goes up in that hole where it'll be in the, you know, if you just plug it in and let it swing by the carpet down there, it's going to get hot and burn the daggone carpet. Anyway, what we did was, he took a picture of the one they had at the Chevrolet place, and it looked like this one, but it had extra holes out here that were far enough apart so you could mount that one, okay? So that was the deal right there. That's one of those times we diagnosed correctly. Now sometimes, the only way to make sure the module is a problem is to substitute a known good module, which may be fried by the vehicle just like the first one does. We've seen that happen here. Or you can pull the suspect module and put it on a good vehicle if you have a good vehicle, but a lot of times we don't. I've done that before. I had an F-150 I was working on that I suspected a bad engine controller because it was firing the coil and all kinds of crazy stuff. And I pulled that engine controller and I put it on another 91 F-150, and the other one started acting like the bad truck, firing the coil and doing all kind of crazy clicking stuff and all. So I went for $100 and got an engine controller from the parts store, plugged it in, and they're still on that truck. And my son drives, that's that white one, and my son drives right now. Even if the module was proven to be bad, there's a question of what caused the original module to fail. Sometimes the module just fails, like the electronic throttle control module, it just failed. Or we know nothing killed it, it just died. You could pull the cover off and look at it, I could see nothing wrong in there. I mean, if you just look at all the little resistors and all. Okay, intermittent short, another bad module connected to this one somehow. You gotta be careful, not waste anybody's money. Now, we're gonna get a little more complicated here, if you guys can focus, okay? Now watch this. 2000 F-250 Super Duty, 19,205 miles, 7.3 power stroke, automatic transmission, 4-wheel ABS. ABS brake light was on. ABS module won't talk to the scan tool, and the PCM sees no vehicle speed. A PO500 means it can't see vehicle speed. And when we did it, you might notice this is like the IDS right here. Well, they called it WDS back then. And this is one I worked on. Look at the big picture. All right. Power circuit 533 is pin 14. Right? This is the ABS system module. And by the way, the ABS system module on this one receives the speed signal from the differential and feeds it to the engine controller and the cruise control and the instrument cluster and all of that. And there's several different ways they do it. All right, so here's 533 is the circuit number. Okay, it's going from C242B through this splice right here, splice S235, and connector C1050. These are basically on that line. So it's going to be one of those, right? Trouble spots on the circuit. Now I decided to check right here and see if I was getting any power to the ABS module. I didn't want to put a $1,200 ABS module on it without first determining that was what was wrong for sure. This is what it looks like going through the connectors. Now it takes research to do this. This is not going to be automatic. You're going to have to know how to find connector pin out. You're going to have to figure out by looking at the red legend which pin that particular wire and that circuit is going through so you can track it. It's leaving the junction box, which the junction box is that big black thing I got over there. I could pull it out and I'm not gonna waste my time doing that. Okay, it goes through this pin right here. And this is the male and the female side of that connector. And it goes through there and then it comes down here to pin 14 on the ABS module. I had nothing here, right? This is C242B, this is 1050, and this is C104. See how that, you're gonna have to learn how to track stuff like this or you're never gonna fix anything. All right, now right here, the fuse checked out okay. And so see, this is where I checked it at. I had to pull the 2 bolts, and I found the little legend here, and it tells you which one. You can look at circuit number, you can look at wire color, you can make sure. Now I use a little tiny piece of wire to touch that terminal because I don't want to cram a test light in there, spread it out where it won't ever work again. Takes some doing, but I got to it. Circuit 533 travels through pin 30 on 1050. One of these 3 big bulkhead connectors that are all stacked up in a row. You have to get to these from out there in the engine compartment though, although they're showing them from the inside right there. The circuit from the bulkhead to the module proved to be just fine. It would carry test light, correct? And so what I had here, critical thinking skills kicked in. Rather than simply memorizing the facts, you got to be able to think. Look at this right here, pin 8, right here. It says AC clutch feed. That's strange, isn't it? You got that? Pin 8, right here. See pin 8? All right, that's 242B. Now when I look at the legend for that connector, all they've put there, they've got a circuit number. And look at this. This is something else I should look at. You notice the circuit number changes and the wire color changes from this side of that splice to the other. So even though it's running out here, when you see these little dotted circuits, that means this wire goes other places. And that little splice right there is where those wires come together. All right, and so what you got here, central junction box. See that same thing? 24, 10 amp, pin 8. Goes through there. C296. Got it? Now, what that's doing, apply the power to pin 8 with C1050 reconnected. I found power in the ABS module. So I woke that thing up. I put power right here, and I got power all the way down here, and that told me the problem was in here because that fuse wasn't blown. Okay? And that's how I tracked all that down. So what's the point? How many times have you heard stories about somebody going to a shop and they threw a bunch of money at one and they didn't fix it? I mean, nobody's ever heard of that, right?
No.
Well, why is it? You know, all you got to do is you got to say, okay, I'm going to go to the trouble to do what I have to do to make sure that what we've found is what it really is. Now, sometimes the only way you can determine for sure if you've checked powers and grounds at the module and the module's still not awake is by putting another module in it, which is what we did on the Chevrolet. You got it? All right. It's a backwards way of doing things when you say, I think I'll try this, 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 and this. And I don't know, I mean, how many times I've seen it. I have seen them where they would come from another shop and they say, it won't start and we don't know why. And I'd have to go back and I'd have to put the distributor back in there in time the right way, and I'd have to go undo everything that they had done, and then I would find the real reason why it didn't start. You know, and then it would be something like a weak ignition coil. You know, it's supposed to jump and scare you to death, remember, instead of being just a quarter of an inch and all that. Okay, so somebody tell me something that you know now that you didn't know when you came in here.
You like hating Chevy?
Huh?
You like hating Chevy?
Oh, not really. I mean, I enjoy
They
working on it.
put that engine control on because it was no way.
Yeah, that was something that you just sort of, that was sort of an engineering fault that I had, you know. But now I was thinking about how Ford changed the entire processor, and GM kept their original, you know, when I say PCM, GM kept their original PCM and put another module on it.